All right. Well, let me just go over and just show you, point to you the calendar to show you where we're at. We're Wednesday, March 3rd. Here's what we got to look at today, like half of the chapter. Then next Monday, we got to look at the other half of the chapter. Now, the midterm is going to follow by the end of the week, okay? I'm hoping everybody's got this all worked out with that a ProctorU record, because you got to have that working, and there's no way around it now. Chapter 2 was a test run for that. If you didn't, because I wanted to add that just in case you didn't do that quiz, because I don't know what it is with folks that just skip that. And I extended it. I can't remember if it was last week or 2 weeks ago, but I extended it at the beginning of the week. And there's still some people that didn't take it. So I have to assume that the people that are doing that are just, they're not that serious about the course, because we have, half of people that show up every time we have class. So I got no way of knowing what's in people's heads. If you got an issue, I can try to help you ahead of time. I can't really help you going backwards, because once everything is passed, we got to jump ahead, move forward, because all of this stuff is going to be covered. No matter how much, we want to cling on and hold to the past stuff, we got to move through this class. It's a 5-hour class, almost equivalent of 2 regular college courses. But as I've said before, once you get out of this successfully, then you're going to be able to take any of the 100 level math classes. All right, so let's go ahead. And jump into things here. And I don't mind stopping and asking questions as we go on this, but like I said, is just, this is your chance whenever we go through something to do that. I mean, we got plenty of time as far as things are going. I went through this yesterday in my Tuesday, Thursday class. It's not that much of a rush, but like I said, we got to finish this by Monday. And then the main drawback that I can see for you folks in the Monday, Wednesday class is you got your weekend coming up before the exam. So when we finish Monday, then you got about 2 days, maybe 3, if we can arrange it, days in order to be able to get ready for that midterm exam. And that midterm exam can make up for a lot of missed stuff, okay? When I say missed stuff, I'm talking about the regular test. As a matter of fact, the midterm is worth 25% of the grade as a one, by itself. If you have a missing test, then it's going to add to that, because like I said, that's the cure-all for a missing test up until midterm. All right, well, we only had 2 tests, but there's no way around passing the midterm and the final and being successful in this class. It's just the way this course is set up. All right, so let's go on over here, and we'll talk our way through these things here. Share. All right, let me get this ready to go. I want to get the bigger one. This one's fine for doing the work in, but I wanted to get the bigger one. All right, where did that thing go? Oh, it opened up in here. Okay, so let me try again. I forgot it opens up in that program, and I got it set to where it's sharing. Yeah, good. All right, so 5.1 and 5.5, they put them together into one. And this is really a pretty logical way to do it, because it deals with the concept of how to multiply, divide, and then deal with negative exponents, which are all part of that process, all in one nice little lesson. Now, this right here is, for the most part, completely new to anything that we've seen. Now, it's still got multiplication, and it's still got addition and subtraction, that type of thing. But when we're dealing with exponents, you know, there are certain rules when we multiply them, and we got to just realize what those are. All right, so let's get started here. All right, so the first thing we're going to look at, and I'm going to share a little file with you. In the chat. All right, so you're seeing there the this is a it's just a summary of all the rules we're going to be learning in this first lesson. I think most people know the zero property exponent. That just essentially means it doesn't matter what the base is. B can be anything, but if it's raised to the 0 power, then it's essentially 1. Negative exponent means we take the reciprocal. In other words, if we have b to the negative nth power, that just means 1 over b to the nth power. And also, too, if something's already in the denominator and it has a negative exponent, then the reciprocal is going to mean take the reciprocal and make it, you know, be back on top, the whole number. It's that same process that we looked at with reciprocals when we're talking about the parallel and the perpendicular lines. The perpendicular lines have a negative reciprocal relationship with the original line. Parallel lines all have the same slope. Perpendicular lines have reciprocal and also sign difference from the original line. This right here just deals with the negative exponent. It just means reciprocal. Then they call this one, sometimes the names are slightly different depending on the book, but they call this third one the product property of an exponent. And another way of looking at it, and it makes more sense to me, is just the product rule for exponents, the product rule. And what that essentially says is that if we have two like bases, in this case, we have b to the m and b to the nth power, the b is the same in each case, the bases have to be the same, then how we can combine those when we're multiplying them is to just add up the two exponents and take that common base. The quotient property of an exponent, or the quotient property, the division rule for exponents, sometimes it's called, well, it's very similar, except it's kind of just the opposite in that if we have two bases that are like and they're in a fractional relationship, in other words, the numerator is to be divided by the denominator, and that's what a fraction means, then we simply subtract the two exponents, or we subtract the denominator from the numerator. Like bases, we subtract those exponents. This one they call the power property of an exponent. If we have an a base and an exponent inside, and we raise to another exponent, then we simply multiply these two things and simplify it out. We'll see examples of these in a second. And the number 8 is slightly related. I'm sorry, number 6 is slightly related. In that, if you've got multiple things inside of parentheses and you raise those to the a to the m, b to the m. All right, so let's look at these little things. All right. I'd learned something this Monday about turning on these what they call the captions. And I don't know where it's at in here. I don't see it. It worked really nice. I was surprised. Because since we had that problem with the audio towards the end of class, I was looking in that. And the computer I have at school, I was able to do it, but I don't see it on here as a choice. All right, well, let's just go on now to the worksheet here. All right, so the first one is going to use that product rule. This is what we had said on that list of rules, that if we have two like bases, in other words, in this case, it's x. First expression is x to the 7th, and we're multiplying it times x to the 9th. The bases are the same. They have to be the same in order for this to work. Then we're simply going to add the two exponents. In other words, 7 plus 19 is 16. So we're putting these together into one when we multiply them by adding those two exponents. So here's an example of the quotient rule. Like bases, both x's, In the numerator, we got x to the 9th, and in the denominator, we got x to the 7th. There's only one way you do it. It's always the denominator subtracting the numerator exponent. So 9 minus 7 is x to the 2. We're going to find out that sometimes you can do that. In other words, if they had been reversed, x to the 7th divided by x to the 9th, when you subtract, you're going to have a negative exponent. We'll see how to treat that in a second. All right, here's that one version of the power rule. We're raising two things in there to the second power. That means we pass on to the 3 the squared. 3 squared is 9, and then the x also gets a squared. That's all there is to do there. Here's the division one that's similar. The fraction is x over 4. So the cube, the exponent, gets passed on to each of the two, the numerator and the denominator. So the numerator, x cubed, is just x cubed. 4 cubed. And this is actually wrong. I found out yesterday. This would be 64 because of the fact that 4 times 4 is 16, but times another time, a third one is 64. So that should be 64. All right, here's where we get to the negative exponent rule. All right, 5 to the power of negative 2. All right, that means take the reciprocal of 5, which is 1/5, and then that uses the negative sign. So all we got left then is just a plain old positive square, and then we go back to using the number 4 rule. So 1 squared is 1, 5 squared is 25. And here's the power rule where we have a power in there and we're raising it to another power. So when you're doing that, you multiply. So 7 times 9 is x to the 63. See, it gets big real quick when you do that. It is possible to have scenarios, as we'll see, where 3 and 6 are mixed. 3 and 6 are mixed. All right, so let's look at this now. This is an example of putting all of them together, or most all of them. I think it does all of them, actually, now that I see it again. All right, so in the numerator, you got x squared y cubed. There's parentheses around both of those, all being raised to the second power. In the denominator is something similar. We got a number down there also, but everything plays the same way. 2x cubed, y squared, all to the cube. So in the numerator, it's x squared squared, and it's y cubed squared. See that? It just multiplies each of those. So this is going to be x to the 4th, and then this is going to be y to the 6th up there. Now in the denominator, it's almost the same thing, but we also got a number down there. We got a constant term or coefficient. So it's going to be 2 cubed, x cubed cubed, and y squared cubed. So 2 cubed is 2 times 2 is 4. 4 times 2 is 8. And we got x to the 9th because it's 3 times 3. And we got y to the 6th because it's 2 times 3. Now, once we do that, then we're going to go back up and use these very first rule here with the division. So the 8 is just going to stay down there because there's nothing else, no other number to divide into it. It's essentially just a 1 up there, so it's 1/8. So the 8 just stays down there. But this is 4, when we divide the x's, it's 4 minus 9, which is -5. We're going to fix that in the next round. Y to the 6th divided by y to the 6th is y to the 0, which is just 1. And so the only thing that we can do is, well, that's just going to be 1. And in order to get rid of the negative sign on that x, we're going to just take it and put it in the denominator. and make it positive, or make the exponent positive. All right. Okay, so let's go ahead now to the problem sets. So what I want you to do is, as usual, try these first couple here. See if you can figure them out. I'm going to give you a couple of minutes there on those. And then once, especially if I hear somebody shout out an answer or put it in chat, because I want to make sure you've got enough time to do it. And one of the things that kind of concerns me, and this is not something I police, but technically everybody's supposed to be tuned in, everybody's supposed to have the camera on so you can see you. But I have to trust you to do that. And if you're off, playing video games or doing something and not paying attention to what's going on here, then you're essentially on your own, because you got, you may be missing something. Now, the drawback of that is you can be in class every day and miss things. That's why you got to realize what's going on with the time frame. You got to know what you're responsible for. That's all in the syllabus. That's all in that calendar. For the most part, the calendar, if you just have that one thing, you're all right. Now, that all pertains to what's going on in my math lab, and the more stuff you do over there, the better off you are. But like I said, you're responsible for being in here and being active. I can't pull things out of people if they're not interested in doing it. But this is how you're successful in the course. Like I said, I know there's always people, they can just put start the session and go off and do something else, which if you have to do that, that's fine. But, you're also being held accountable for what goes on in the class. So with that being said, try those first couple, and I'll give you, I'll go through them in a second. It would just be nice to have an indication that people are actually alive out there. Anybody got anything yet? All right, let's go ahead and do that. All right. All right, so this is x to the 4 plus yeah, great job, Tanisha, on that one. And it doesn't matter how many there are. You could, for example, do the y to the 11th times the y, and that's, you got to remember, you don't usually write it, but that's 1. All right, so that's going to be plus 1. But with addition, the addition rule, since that's associative, you can, or commutative, it doesn't matter the order you add them up, it's going to be the same. So that's y to the 19th, because that's 11 and 7 is 18, and that's 1, like I said, is. You can't skip that one. And I know it's a bit confusing because when we deal with just a plain old y, you don't write a 1 up there. It's like when you have a coefficient of y, or when you just have a plain y sitting out there, the number in front of it is actually a 1. So also is the power. All right, so the next two are using that division rule. Okay. In other words, this one right here we looked at. And again, if you want to just use that as a reference guide, that's a good thing to have. So go ahead and do those next couple there. And we'll see, because I see I got messages, and I'm glad y'all are working ahead. That makes me feel good that y'all are working. But I wanted to just kind of go with a little bit of a, we're not in that much of a rush that we don't have time to go through things. All right, this is using that division. So it's x. There's the numerator, that 21, minus 9 is equal to x to the 12th. Good job, Valshan and Tanisha. Yeah, y'all right on that. All right, now 4 is going to be similar. And I got a couple of people who's got some answers there, but I need to look at it and see. I think y'all are right. So the 4 minus 3 is just a plain old x to the 1. That's a 1 there. And then 8 minus 5 is y cubed. Good job. Again, Tanisha and Velshan. Good. All right. Well, I'm going to give you a couple of minutes on more minutes on the 5 and 6. All right. This is using essentially this number 6 rule. Okay. Like I said, it was also the, number 3 here, the problem 3. Okay, so remember what this rule states. It means that that 3 gets passed on, that exponent 3 gets passed on to both of these. Now the x, we can't really simplify that anything anymore because, or any further, because we don't know what x is, so we just leave it like that. If we find out what x is, then we can simplify it, but that's not part of what we're doing here. So x cubed is 27. 3 times 3 is 9. 9 times 3 is 27. All right, now, just Tanisha, I see your answer there on number 7. Watch. Watch which rule you're using, okay? Hint, hint, hint. All right, we'll get him in. It's really actually simple. We'll get to 8. That's the same. That's this old, the second one here. All right, so this just passes on to both of those. It's x to the 4 and 2 to the 4. Can't really do anything to that numerator because we don't know what x is, so we're just going to leave it x to the 4th. And then 2 times 2 is 4. 2 times 4 is 8. And 2 times 8 is 16. All right, y'all are really impressing me today with this. Good job on these. I mean, the attempt is the most important thing. All right, and just remember, the negative sign does not affect the entire value sign. That negative in the exponent only means take the reciprocal. Okay? Now, it looks like y'all moving ahead, so I'm going to try to catch up here. Anything to the 0 power is equal to 1. You could have negative 1,000 to the 0 power. It's still equal to 1. Doesn't matter what's inside. But those parentheses are clear that it's that whole number. So the only thing to come out of that is just 1. All right. So one of the things that I recommend when we're going through exercises like this, if you have a negative exponent, you're simply going to apply that first. So that simply means this. The exponent of 6 is 1 over 6. Now, technically, it's still to the first power, but there's nothing else to be done. If you got 1 over 6, that is 6 to the first power. So that's all you're going to do there. That negative 1 just means take the reciprocal. If that had been a negative 2, then we would have a 2 here, and then we would square it. Or if it was any other number that we had to do something further, but, to the first power just means one thing. All right, now these are a little bit harder because they're putting together, well, not so much 9 and 10, but go ahead and jump on 9 and 10. I'll give you a couple more minutes, and when I start seeing some answers up there. But just remember this. 0 power means 1, okay? All right. I'll give it another minute, and I'll start hitting those. Okay. Now, the only thing that's being raised to the negative 2 power is just the x. The 4 is unaffected. Now, you can kind of do this in 2 steps. So this is 1 over x squared. And it is, if you remember, the whole number is 4 over 1. You don't really need to do all this unless you really need it. So the way I might rather deal with this is just take it and put it in the denominator and make it positive 2. So it's 4 over x squared. Yeah, good job, LaShawn. I see that. That's good. Impressive. You got that one. All right. Now this means the whole thing in parentheses is being taken reciprocal of. So in other words, so we're going to square both of those because the only thing the negative sign does is just give us a reciprocal. So instead of it being just negative 3x, that to negative 2, it's 1 over negative 3x squared. Now we've got to go ahead and pass along to every one of these using essentially this rule right here, 6, and also 5 Actually, it's just this one, because these inside don't have any power. So it's -3, and we got to put the whole thing because it's in parentheses. The x squared is going to stay like that. There's nothing much we can do with that. And then -3 squared is 9. Anything squared is always positive. All right, Tanisha, that's impressive. Good, good, good. All right, any questions? Hit on 11 and 12. Some of you may have gotten them. Those are taking a little bit more time. 11 is really not so bad. That's just really, to be truthful, it's not much different than this one up here was. The only thing that's going to be different is you're going to have a negative exponent. So you're going to have to apply the negative exponent rule. Remember, that just means put it in the denominator, or if it's in the denominator, you put it in the numerator if it's negative. All right, so this is x to the -3. And then this is just essentially a 1, okay? And the reason why I'm putting it there in parentheses is because it's going to stay in the numerator while this goes downtown, goes in the bottom. You mean on number 11? That's a 6. It's a little bit bigger there. All right, and number 12, well, we take either the longest because it's sort of like that last example one, the last example problem. All right, so the first thing I'm going to do is pass the 4 along to everything. There's just 2 things in there, but and I'm using the parentheses because of the fact that I just got to pass that along to both of them to just show it. You could essentially just go 4 times 3, and that's going to give you 12, and 2 times 4 is 8, but I'm trying to show some intermediate stuff. And then the 2 gets the cubed, which is going to eventually give us an 8. So 3 times 4 is 12. 2 times 4 is 8 up there. Downtown, we got 2 cubed, which is an 8. And then the x is just x cubed because I just pass it on to that. Since essentially that's x to the first power, 3 times 1 is 3. So x to the third. There wasn't much I could show there. All right. Now we still got more than one x, x is in different places. So in order to combine them, we got to use that quotient rule. Light basis, so we're going to subtract when we divide. And then this is y, 8 minus 9. And then the 8's still down there, okay? All right, I'm going to have to come over here to get a little bit of room. So 12 minus 3 is x to the 9th. And then I got a y, 8 minus 9 is -1. The sign is very important. You can't forget about that, the sign, because that sign means that it takes a reciprocal. So this y is going to go down there with the 8 now. Yeah, good job on that one, Wilson. All right, any questions on those? We can go back over any of them you want to. All right. All right, so let's look at the next one. Let's see, let's make sure I'm doing the right stuff. Yeah, 5.6. So we already got these two, so we're doing pretty good. 5.6 is not that bad. What I'm probably going to do is also do 5.2, so that way on Monday, we've only got those two left. All right. So 5.6 is called dividing. In other words, we're going to take an expression of some sort and we're going to divide by a monomial. Now, really, we're not doing anything other than using this rule here for multiple times when we do that. So that's the good news. You're just taking and dividing multiple ones, but everything's getting divided by the same thing, the same term. So in other words, if we divide 6x squared plus 4x by 2x, then that's how it looks when we set it up. The 6x squared plus 4x in the numerator, the 2x in the denominator. Now that means then we can set them up separately if need be. Again, if your skill level is such that you can jump from this to this, more power to you. But the steps are to make sure that you have a justification for everything you do, and it can be very, very, tedious to do this. I think one of the reasons that people don't like math so much, and I'm like that too, is the steps are kind of needed to be there if you're not very proficient at it. So it's easy to throw up your hands and say, oh, I can't get that. But you got to have some amount of patience when you're dealing with math. All right, so 6x squared divided by 2x plus 4x divided by 2x. All right, so we're playing the rule, the division, the quotient rule twice here. So 2 goes into 6 3 times, and that's the same old regular old math. But right now, then, we got x squared divided by x to the first power. So 1 minus 2 means we got x to the first power left. So 3x plus, and now you notice is the x's are the same, so that when we divide that and subtract, it's just going to be 1. So the only thing we have left is 4 divided by 2, which is 2. Okay. Now, on this one's just got 4 terms now, so we got to do it 4 times, taking this whole thing and dividing by 5x squared. So all of those up there divided by 5x squared. Means that we can set it up like this, and it's in an immediate step. 30x to the 6 divided by 5x squared plus 15x to the 4th divided by 5x squared. Negative 5x squared divided by 5x squared. That's just going to be one negative right there. And then 10x divided by 5x squared. And we'll talk a little bit about that, why that does that. But that's that negative exponent rule, as we're going to see. So 5 into 30 is 6. As far as the exponents, it's 6 minus 2. So x to the 4th. 15 divided by 5 is 3. x4 divided by x2, it's 2 from 4, which gives us x squared. Now that right there, remember, anything divided by itself is 1. So 5 divided by 5 is 1. X squared divided by x squared is also 1, because 2 minus 2 is 0. X to the 0 power is 1. So you'll just notice in that, hopefully in that little explanation, that, you know, the rules of mathematics are consistent. You know, no matter which way you approach it, using which specific rule, you're still going to come out to the same thing. So that's -1, because there was a negative sign there and a positive here, so that's why that's negative. Now, it's 10 divided by 5, which is 2, but what we've got is x to the first divided by x squared, so that's 1 minus 2 is x to the -1. Since it's x to the -1, it goes down in the denominator, and we are done. All right, so what we'll do, go through 1 through 3 on your own, and then we'll take a little break. So I'll give you a few minutes on that. And so I know I've said that this is a lot of material, and it is, but if you present this right, you know, it doesn't really have to be that complicated. All right, let's see. And I can make them a little bit bigger. It's just sometimes you can't. Yeah, that's I should do it. You can't make it too big, or you'll lose part of one. I can see it on my little. So this is 4. And I'm just showing you what's happening like I did when we went through that section where we learned about the division rule. That x in the denominator, that's just x to the first power. That's where that one comes from. Yeah, good, well, Sean. Now, just to kind of give you a little bit of heads up on this. In these homework type problems, these should all be different. You won't be able to put them back, add or subtract these because they're not going to be like terms. We're going to see in the section that we get to before the end of class that with adding and subtracting, that's all you're doing is just putting together like terms. So 16 divided by 4 is 4. Eight divided by 4 is 2. And remember, again, the 4 to the x in the denominator is 4x to the first power. So that's where that little 1 comes from. Oops. So 4 divided by 4 is 1, and x divided by x is 1. You could put x to the 0 power if you wanted there and then make it a 1, but all right, let's see about number 3. And then I said we'll take a little break. Voice is starting to crack. Now I'm going to put just a plus here, and then I'll worry about the sign in a bit. All right, so we're going to have 9 divided by -3 is -3. And then this is x to the 3 minus 1. This is positive divided by negative, so it's negative. 2 divided by 3 is 2. And then this is x. And then negative divided by negative is positive. The x's are going to take each other out. So the only thing that's important is the 12 divided by 3, which is 4. So that's it. So any questions you got, ask it. Well, like I said, we'll take a little break. Thanks, Karen. I just had muted my mic. All right. So just note that thing on there that next week is the midterm week. So we're going to have to test in about a week on everything. Okay. Everything up until this point. That's the way the midterm and the final exam work. The final exam work is going to cover everything. Now, the good thing about it is, for the most part, is you're doing the chapter 1 and the chapter 2 material when you do in chapter 5, and you do in chapter 3, and you do in chapter 2. Then chapter 3 is kind of a standalone thing, and as far as graphing is concerned, but you're still using a lot of those techniques throughout the course. So just remember, this is essential to be prepared for this thing. You're not going to prepare in just 1 or 2 days. In this class, I would recommend being on this material now, chapter 5. And working on it diligently and hopefully complete by the weekend, so that on the days leading up to the exam next week, you can be working on the review, or there's some kind of practice element for sure. I can't remember exactly what there is offhand. All right, so is that all clear? All right, let's go back to the board. And finish up these things. This is going to be hard to get all these in here. I'm going to save these, and I'll bring these up on the board. That board I was just brought up. Matter of fact, I'm going to do each one separately. Well, we got enough to do the first one here. We got enough room. All right, y'all hearing me now? Okay, good. Yeah, I don't know what's causing the problem with my microphone. I went through several different microphones, and every one of them, it's like every setup I was trying, it wasn't, the audio wasn't working. So I just went back to my little Chromebook, and I'm giving the audio through that, and well, actually I'm doing the video through the regular computer. But I use the little Chromebook just like I use my other computer, just so I can see what you're seeing, so that way, it's just hard to do that with the audio, because you can't have the audio on too, or you get feedback. All right. So I'm going to go ahead and lay each one of these out separately. Put a plus there, and then we'll worry about the signs in a bit. Everyone's getting divided by the x, the negative 4x squared. That's going to end up being positive, but we'll worry about that in a minute. All right, so this is going to be negative. Well, 6/4 is not a whole number, so we're just going to reduce it down to 3/2. And this is x5 minus 2. This is positive divided by a negative, so it's going to be a negative. 8 divided by 4 is 2. And then this is 2 minus 2, which is just going to be 1 there. And this is negative by negative, so it's going to be positive. So it's 2 over 4. Again, we did a fraction. So we're just going to leave the 3 halves. That's the preferred way to do it, rather than 1/2, 1.5. And then this is negative 2 times 1. See, x to the 2 minus 2 is x to the 0, which is 1. All right, so let's take one more trip here and whittle all this down. Like I said, we'll have to go onto another board to do that because we don't have enough room. And then the x is going to go in the denominator since it's negative. And there we got it. All right, questions?
So it wouldn't be negative 3 over 2?
What's that?
It wouldn't be negative 3 over 2x third?
For the first term?
Yeah.
Oh, I'm sorry. Thanks. Yeah, it's negative. Thanks. So that's a good question. All right, so now I'm going to go over to the board, or this jam board, and I'm going to put those problems over here so we'll have more room. All right, so let's look at the one on this side. Has anybody got an answer for either of these? To either of these yet? So let's just set it up. So this is what this means. All over negative 4x, which means 24 x cubed minus 4x. And just to kind of show you, and I mean, I'm glad that y'all caught me on that. But one of the things that happens in math, and this happens with just general in life when you're writing things down. See, I neglected from here to here to write that negative sign. So when I'm going up and looking at the last line that I wrote, I'm believing what I wrote, even though what I wrote was not right. So that's why it's important to be able to double check, because if I was taking the test with you folks, we can't talk to one another. So I would have had a deduction on that, right? So everybody can make those kind of mistakes. And that's because of this human fallibility that, when we write something down and we wrote it down in good faith, we're going to believe that, and that may not be the case. That's why mistakes are made. I'll worry about the sign in the next step. So that down there, all the same. So that's right so far. Negative into positive, so the whole thing's going to be negative. 4 into 24 is 6. This is x3 minus 1. I'll handle that in a second. It looks like, Cristiano, you're doing good. You think you got it, but 8 divided by 4 is 2. I'm just trying to be super careful, but you see, even if I'm super careful, there's a chance of making a mistake. Negative divided by negative is positive. 4 divided by 4 is just 1. And then we're going to leave that x down there because there's no x to subtract from it. So it's going to stay down there. So see that? Did I write it down? Oh, wait a second. See, this part is 1. Yeah. Okay. I'm sorry. Look at that. I wrote it down wrong up here. So you were right. Sean, hold back. Hold on a second. It's negative 4x divided by 4x. So I want to make sure. So Valjean, how did you make this? All right. Okay, so negative 4 divided by negative 4 is plus 1. X divided by x is also 1, so that's the same thing. Okay, so it's plus 1. So you're right on that, Kishona. All right, let's see what happens with number 6. That looks good, Valjean. I was thinking that was what you had for 5, but I think you got the hang of it if you know how to get that x down there. See this? I don't know. For some reason, I was thinking this one was that one, and that's why that last term. I was thinking that, but this is the one that doesn't have an x. All right, I'm just getting tired here. We need to slow up. That's one reason why I like to take a break, because it's hard to go, more than an hour of doing math without taking a little break. Maybe an hour and 15 minutes. So that's why we take a little bit of break. But that little break didn't heal me back up. So 3 into 6 goes twice. X to the 2 minus 1. 9 divided by 3 is 3. X divided by x is just 1. We'll take care of that in the next. 3 into 12 is 4. And then the x just stays down there on the bottom, because there's not another one to pair it with up there. you could put x to the 0 if you wanted to, and then 0 minus 1 would give you a negative x to the negative power, and then you can put it down there, but that's kind of a long way about doing it. Yeah, so just check on that, Valshan, because you still got an x there for the middle term. But really good job on that last thing. All right, questions about any of those? Wait a minute, you know what? I didn't finish this. There we go. All right, any questions about any of those? We're doing really good on the time, so if you got questions, let me know now, all right, on any of this. All right. So like I said, if you want to keep this thing around for chapter 5, it'll be useful. Now you're going to keep using them throughout the semester, occasionally at least. So those rules are important. All right. All right, so what we got here, okay, there we go. That makes it bigger and it takes up the whole screen. That's what I wanted to do. All right, adding and subtracting. Now, really, adding and subtracting is surprisingly easy because you already know it from chapter 2, which is this concept of like terms. You remember if you had a 7x and an 8x, you would just add the two and have, what is that, 7 and 8, 13x, 15x. Well, the same thing is going to happen here, and that's all that addition and subtraction is. That's why really this is not anything new for the most part, but we're putting it within the context of polynomials, in other words, with multiple terms. All right, there's both addition and subtraction. Addition, what they do is they'll show you these two things. They got one in parentheses, and then they got a plus between it, and then they got another parentheses with 3 terms. And sometimes you'll have some that are alike, and sometimes you won't. Now notice on this one, you got a 6x cubed, 5x, and then a 7. There's no x squared term here. But on this side, you got an x squared term, but you don't have an x cubed term. You got an x term, and then you got a constant term. So the only ones that go together are the 5x and the negative 9x and the 7 and the negative 1. Now, they put these things in parentheses. I don't know why they have to get that particular, but that just means the 6x cubed is coming down on its own. It doesn't have a mate. And the 8x squared is coming down. It doesn't have a mate. So those are just going to go right here, the first two. But these, the 5x and the negative 9x, they're like terms, so it's 5 minus 9, negative 4x. Nothing really new there. And then 7 minus 1 is 6. And there we got it. Now, this is something that you've done before, but I have to just kind of reiterate, people often make mistakes with these things because when you're subtracting, and that's what the difference is, in this case, you're taking 6x cubed 16x cubed plus 5x squared minus 6x plus 7. And we're subtracting 10x cubed minus 4x squared minus 7x plus 11. In other words, we have to pass that negative sign off to each one of these terms. In other words, it's negative 10x cubed. It was a positive 10x here, but since we're subtracting it, it becomes negative. We got a negative 4x squared, and we're taking the negative of it, so it becomes positive 4x squared. We got a negative 7x. We take the negative of it, we got positive 7x. We got negative of a positive, which just gives us a negative on the 11. Once you do that, you just collect like terms, and that's what they're doing in the parentheses. On this, you got a made for each one. So 16x cubed minus 10x cubed, 5x squared plus 4x squared, negative 6x plus 7x, and then 7 and negative 11. They've lined them all there, and then what do we got? 16 minus 10 is 6x cubed. 5 plus 4 is 9x squared. Negative 6 plus 7 is 1x, just one single x. 7 minus 11 is 4, negative. All right, so let me put that one on here. And I'll bring it up. And I'll give you a few minutes to work on it. We're doing all right for time. So now we're going back to 5.2. So they're going in some strange order. And the reason being is that if you do this right, you kind of group the similar ones together. So that's a common technique that teachers use to be able to, especially when you're trying to go fast. So look at those first three. I'll give you a couple of minutes and we'll see how many of these we should be able to finish. We probably should be able to get all of these in. And like I said, and then use your weekend for catching up on this homework. And I would, if I were you, I would recommend just getting everything done as far as you can. So that way, when we come back Monday and do the last two sections, if you have any questions about those sections, you can answer them pretty quickly and then jump on your practice, for the exam. All right, so anybody got any answer yet? What happens on this one? So remember, you're doing like terms. You don't really need the parentheses unless you like it. But those two are alike. And then we got negative 6 and negative 3. And those two are alike. So what do you have? 3 and 2 is 5x. These are both the same sign, so we just add them. All right, good job, Krishna. That's it. These are all addition and subtraction. I know that that's why I don't like what they did in that last section where they use that division sign, because the division sign, especially when the font is weak or if it's not blown up enough, the division sign looks like a plus. So What about on this? See, those are alike. Those are alike. So what do we get? So we're just adding. So essentially, you could drop the parentheses and then just collect like terms. All right. So these two go together. So 6 and 8. It should be plus. I wrote a, so 6x plus. So that's 14x. -5 plus 2 is -3. Good, Amari. I really like it. I'm getting responses from everybody in here. Y'all are really on the ball. You're a little quiet, but half the battle in math is showing up, but half is not good enough. You got to get at least 3/4. So the other quarter is, preparation and making sure you're ready for tests. And then, of course, if you want more on top of that, like to get, in the A or B range, you got to have more. You got to make sure you do well on those vehicles, the tests. And this midterm exam is a good way to make up if you made mistakes, because oftentimes what will happen in a math class is people will take the first test and then they'll not kind of know what to expect and nervous and don't do so well. But the midterm exam, that's what the department looks at. So they're proctoring it. So you make sure you're not getting any help. So they know you're doing the work. And one of the reasons why I did that dry run on test 2 is because the Proctor U sends me over the video, and they said, and if there's a flag on somebody, they'll say, oh, this person didn't show their ID. You got to show ID. The reason why is because you got to verify who you are. Or this person was talking, or this person left the room. All no-nos. Now, I know some people tend to talk from, to themselves. And if you're at home, especially, like there was one flag I got on a student. It wasn't in this class. But, I just went through and watched her, and it was pretty obvious she was doing her own work and stuff. She just talked to herself a few times. So I did send her the warning, but like I said, because if for the midterm and the final exam, I'm not the only one that checks those things. Everybody that, my boss gets those innocent reports too. No, it's not the boss, it's the head of the 097 committee. All right, so on this one, so those two are together. All right, so this one's negative and this one's positive, so all right. So I'm gonna give you a couple of minutes on that. I'm not sure, I'm not seeing any answers, so I'm not sure if I'm giving you all enough time, but go ahead and even if we take 5 minutes, we should be able to finish this whole thing. So if I see something on 5, then that means that looks like a good one on number 4. So I'm just going to put in these two together just to show you. See, those are alike terms. They're both x squared terms. All right, and then those are alike. So this is negative 12 and plus 3, negative 9, and the common term is x squared. 5 plus 11 is 16. All right, what happens on number 5? Anybody got any ideas? Yeah. All right, I'm going to move ahead because I forgot about this last line. I'm just going to kind of do it like this. So these are alike. There's no like term on that, and these are alike. So 6 and negative 2 is negative 2 x squared. There's no negative, there's no mate to the negative 7x, so we're just going to put it there. And 12 take away 4 is 8. All right, now try to go through all of these in the last few minutes we got. This is subtraction. So what I would do if I was you is I'm going to go ahead, write these things down, and then I want to change the sign of both of those because see that's in front of the parentheses, so it's subtracting both of those, so it's applying a negative to each one. Negative of a negative is positive. Then combine like terms just like for adding. So x minus x, well, there's nothing left. All there is just 9 plus 11 is 20. And that's a great job, Christina, because that's hard for people to see because they think, well, what happened to the x's? Well, the x's took each other out because it was a positive x and a negative x. It was subtracting. Same thing could have happened with addition if you had an x over here that was negative, because really addition and subtraction are the same operation. Subtraction is just addition of the opposite sign. So you got to apply the negative to both of them. Positive 3, so it's negative 3. Then combine like terms. What do you get on that? 3 minus 2 is just a plain old 1x. Minus 7 and minus 3 is minus 10. All right. So there's no x squared term over here, so that's going to have to be just by itself. We're going to find out. All right, so the most important part about subtraction is applying that negative sign to both of those. And after that, it's just a matter of putting together like terms. This one doesn't have one, it's by itself. -5, -4 is -9. Yeah, good, Amari. -3 and -3 is -6. Great, great. All right, on the last two, I'll give you 3 minutes, and then we'll use the last 5 minutes going over these two. This one's got 3 terms that you're applying the negative sign to. And what I would recommend here is you got to apply the negative sign twice. First to the one in here, and then on that one separately. And then combine like terms. All right. If you get one on 9 and 10, let me know. All right, one more minute. All right. I'm just going to write these out as they are. And then apply the negative sign to all 3 of those. Minus a minus is a plus 2x. And then -6, -6. Now we combine like terms. This one doesn't have a mate on the other side. This one doesn't have a mate on the other side. This one's got like terms. This one's got like terms. So we're just going to take the ones that appear only once. And stack those here. They still come along for the ride because they're part of the expression. You know, if you're not adding or subtracting something to that term, then it's just going to be that term. -6 plus 2 is -4x. -2, -6 is -8. All right, I'll give one more minute on this number 10. All right, let's see. So like I said, this is a standard way to do this. Anything before, you're just going to write it down, just like it is. Now, we got two negative signs to apply. Why they did this too is just to kind of give you a little extra challenge. But we're going to apply the same thing would happen if we just opened here and closed here and just had one negative sign. All right. We're just going to do it two separate times, but it's going to have the same effect. So negative 3x squared, negative of a negative is positive. Negative of the 7x. And negative of a negative 3 is plus 3. All right, so now we just put together the like terms. Here those go together. Here these go together. And here these go together. So 2 minus 3 negative x squared. Looking good so far, Krishona. There's no, oh, no, yeah, there's 3x and negative 7x. So 3 minus 7, negative 4. I can make that a little bit neater. And then, oops, you know, no, that's fine. And then the 5 and 3 is 8. Good. All right, we all doing good today. I want to see y'all doing this for the rest of the semester, because I don't mind if you're quiet. I mean, I know with things, people working at home, there's distractions and all that, and that's one reason why I like to have a little bit of flexibility on when we can have the tests. When you pick the time that works best for you. But also, too, I mean, the most important thing is you in here being active. All right, so that's the end of class. If you got any questions, let me know. I'm going to